Now that we've seen and heard Xenon in action, albeit just quickly dialing in some settings, and in fact those settings only having a marginal effect on the output audio, let's look in more detail now at what all the functions are. We'll start at the top with these two detector buttons, labelled order, or at least it looks like it's labelled order. There is actually some Roman numerals in front of that for second order, and there is also an oversample option too. Now, to be honest, I don't hear any difference with this second order button when using it on or off, so feel free to try it. What PSP state is, if you choose this button, that second order one, then the envelope detector incorporated will use second order filters. Like I say, I can't really tell any difference between it being on or off, which, to be fair, PSP also states by saying any difference in aliasing that could possibly occur is hardly perceptible. Like I say, try it out. Now next to this is the oversample button, which, when active, oversamples to automatically compensate for intersample peaks. Now you might be asking, what are intersample peaks? So rather than giving you lots of information about it, I've put some information on your screen, so pause the screen and have a quick read through. And then moving to here, we find these three transient button options that we glanced at in the last tutorial. The first one, React, makes the transients clip hard and consequently produces perceptible distortion, which can work well on synth lead lines. Again, it's something you need to try out with the material that you are working with. And then you next get these two predict options that subtly differ but use look-ahead detection to limit the transients in a smooth way. The Transient Dial is here and works on a percentage scale. This dial operates the initial limiting that takes place of the two limiting stages. As we saw in the last tutorial, the further you dial this up and get higher percentage values, then you'll notice more transient distortion occurring. So if you really want as little distortion as possible, use low percentage values. The trade-off of this, though, is the transients will sound softer in that they'll get reduced in level. And then the release dial is here and indicates in milliseconds. Like most of these functions, it's best to set them up by ear. However, if you know the BPM of your audio, it's possible by using the equation I showed you much earlier to calculate in milliseconds a short response time here, so that the release falls in between and close to alternate beats. Now don't forget, whilst I'm telling you all this, remember this dial affects just the first limiting stage though. And you'll find if you set it to a low millisecond release time, you'll get a louder level, well, a perception of level anyway, but you will introduce more distortion as a consequence. Obviously, the antithesis will mean better clarity, but the perception of loudness will be diminished. The in dial here is actually slightly more than just a way of boosting or cutting the audio signal entering Xenon. This is because even if you have a strong signal that dances around 0 dB, if you dial it above 0 dB, then you'll drive the limiter harder. I'll get back to that in a second. For the moment, if you want to visually see how far away from 0 dB you are, you'll use the input level meters on the left here and see where the peaks reach. But also, just below, you'll see a readout of the level reached. And if, for example, it indicated -2 dB, then pushing the dial up by that 2 dB will get you back to that optimum level of 0 dB. If you push it higher than what's indicated, you will push it harder at the initial limiting stage, and you'll see the amount of gain reduction or attenuation indicated here. Over here, you'll find this word length section of options, which add in dither once any word length reduction has taken place, if bit truncation occurs. Now, I won't go into too much detail about dithering here, but essentially dithering adds in filtered noise at very low levels to disguise any problems of bit depth truncation. I know that adding filtered noise sounds like a bad idea, but at such integrated low levels it actually sounds more musical than without. To switch on, activate the Quantize button, and then you can scroll through the bit depth options for your particular file type. 16-bit, 24-bit, etc, etc. Noise shape here also features clickable options. The C option is the one modelled closest to human hearing, so it's suggested to use that one, although that doesn't stop you experimenting. And here you'll see this auto black option. Now this, when engaged, automatically switches off the noise shaping when total silence is detected in the file, and this will help to disguise the introduction of low-level dither noise during non-silent parts of the audio. Okay, and moving to the leveler section now, we see this leveler dial that indicates as a decibel range. This dial allows you to adjust where the threshold will occur for this leveler function, and you can see that set fully clockwise turns this off. As you reduce its value from off and lower the threshold cutoff point, the lower that the threshold is set to, then more leveling will occur to that part of the audio that raises above it. That said, the leveler function isn't instant, it's quite slow, and will therefore gradually and gently apply the smoothing out of level. The link dial here, which operates as a percentage value, affects the first stage of the two-part limiting that Xenon does, and it's this link dial that allows you to equally limit the audio on both sides of a stereo field. This means in practice, if you've got a short spike occurring on one side but not on the other, the leveling will still apply equally to left and right channels. If you dial it the opposite way to 0%, then the left and right channels will be limited or affected completely independently at this first limiting stage. So in our example, that stray transient on one side will only be affected without affecting the other side. Now I know this sounds perfect, but do be aware the left and right balance might slightly rock back and forth as this happens, albeit momentarily. On the positive side though, when set at 0%, with the left and right channels distinct from each other in terms of processing at this first limiting stage, you'll experience a perceived louder output level, so you decide where you want to dial this to. 0% for complete separate left and right processing, or completely together at 100%. Now, as noted in the last tutorial, the out dial allows you to set the output volume ceiling to 0 dB or below. Now, I tend to reduce this to around about, well, minus 0.3 dB. Certainly if I know I'm going to be sending this over to a CD. Analog CD playback isn't always as accurate as it could be, and that slight discrepancy, or just under 0 dB anyway, allows any problems with intersampling to be negated. That said though, PSP recommend you switch on the oversample button rather than lower this from 0 dB. Anyway, that's up to you. And then you'll see this auto button just here, which allows you to hear at the same volume level, or perceived volume level anyway, your original audio and this Xenon processed audio, so that you don't get tricked into thinking the louder version, i.e. running through Xenon, is better. Don't forget to switch it back off again though when you do process the track. Right, that's a lot of information, so I'm going to leave it here and I'll see you in a second.